So the first part will be presented by myself on why do most AI initiatives fail and also what to do about it. And then I will hand over to my colleague Lucas to give some real-life examples, but also to jump into the product demo to really show how we solve those issues in real life. Perfect. So agenda, first want to talk about the opportunities and challenges with AI, then the keys to AI success, and then as mentioned, handing over to Lucas for some examples and the very exciting demo of our AI platform. And then we're ending with the Q&As. So as Johan mentioned briefly in the introduction, without a doubt, there's a massive opportunity in the economy when it comes to AI. So it not only pops up in the news everywhere that all the big companies are doing so, but it's also a big dollar amount behind it. So in this research, on this research from PwC, they expect a GDP impact of AI of $15.7 trillion by 2030. And on top of that, what will be even more important, and I know today we focus also on small, medium enterprises and startups, is that it really kind of makes a difference if you are the first mover in this AI space. So what we normally see in AI specifically is that the first mover advantage is around 120% of positive cash flow impact. And that's a lot if you compare that maybe to other initiatives. Maybe if you want to move to cloud or if you want to, a data-driven company, AI is really kind of a multiplier of everything what we have seen before. And again, this is why it's so important, even for smaller companies, not only the large enterprises, to really take advantage now, because what is also very apparent is that there might be a winner takes it all approach with AI. So the hurdles are quite low, and this is what we're going to discuss today. But the benefits of really starting early and being a first mover in the space is really kind of very, very big. So if we already covered now that there's a massive dollar amount behind AI and that a first mover advantage is clearly there, what is holding companies back? Why is not every company fully AI driven? All the departments are only functioning with AI? Because what we're going to see is there will be some issues, or there are issues when it comes to AI integration, implementation, making use of AI. What we hear from most companies when we talk to them, there's normally 3 areas that most of the times come up. The first one is the complexity, meaning that a lot of companies start AI projects, but 85% of those projects fail. And we go into detail why those projects fail and what we can do about it. But primarily, the reason is there's no standardization of processes. There's a silo team that maybe runs away with a specific interesting use case, but there's no process around how to implement it and how to measure it and how to make sure there's a business value behind it. The second reason why a lot of AI initiatives fail is that there are simply not enough data scientists in the world. At the moment, there are more than 3 million job openings for data scientist role. So, and this goes across all industries, across all sizes of businesses. So this is a massive, massive shortage of data science skills. And the last part is, even if you have a great data scientist team or one single data scientist who is a superstar and you identified a great use case, you build a model, you can run into issues, or you will run into issues when it comes to deploying those models and making sure they're compliant, they are well governed, and this will only increase. There's tons of regulations coming around fairness and bias and making sure nobody is discriminated, which is extremely important, but this also increases the risk that those AI initiatives will fail. When we go into the complexity part, so I assume some of you are maybe familiar with data science and how to get from the data to value, what I showed in the previous slide. But there's actually a lot of steps in between what to do once you have a data set and you identified a specific use case you want to tackle, what you actually have to do. So first you have to, of course, connect the data, then you have to prepare the data, then you have to make sure the data is all up to date, and we call it feature engineering. Then you create the models. Of course, you also have to choose the right model. You have to deploy the model. You have to monitor the model so it's all up to date and it's governed and in compliance. And then at the end of the day, you also want to make sure that it has business value behind it. And along all of those steps, there's multiple risks and problems that can arise. So You can, have issues with writing custom code for the data preparation. You can have issues with the documentation to make sure that it's actually, visible what you've done in the past. And all those problems will arise once you are in the process of data to value. And on top of that, not only is it difficult to go from the data to value, you also want to make sure that the right AI use case is identified. And as we will see, everything basically where is data behind it can be leveraged and used in order to make better prediction, have better outcomes with machine learning applied. So you also not only have to make sure that the process from data to value is in place, but you actually choose the right use case so that the company you work for or your specific department is successful at the end of the day. So we now discussed that there's a huge opportunity. There's a huge opportunity for first movers, but there's also a lot of pitfalls that you can come across. So the big question is now, of course, how do you solve those problems? And what we saw now is that the reality from data to value is mostly not a straight line, or at least it doesn't seem to be, but it actually can be. So it doesn't have to be so complex as I just described. There are solutions out there which make it much more easier to come to value much quicker than it used to be. How does it look like? So the big difference, what we really want to bring home here is, and this is something what everybody is already used to, is user proven as a service model. So what we really believe in at DataRobot, but also broadly from an industry perspective, is that, we have a team of 700 data scientists. We invested hundreds and hundreds of millions in our platform, and so did other players, to really help you, help companies, help data scientists, help analysts to get quicker to value. So meaning all the things we discussed in the last 10 minutes, the preparation of data, connecting the data, creating the right models, using the right models, deploying the right models. These are all steps that can be automated and can be used as a service model. So really what we would recommend is, go and use as a service model. Don't try to build everything yourself. You also wouldn't try to build your own data warehouse or your own infrastructure, your own compute. You normally would go to AWS, GCP, or Microsoft to buy those services. And the same is true also for AI. So really kind of make sure to leverage the heavy investments that all the players did in the past. And by doing so, really get quicker to the value. Don't take months or years in order to deploy a model, but rather take days or weeks by following the as a service model. And then on the use case part, so that was the complexity, taking the complexity from data to value out of the picture. From the use case part, this is also very straightforward. Instead of thinking, what is maybe a great use case for the company or for yourself, which provides a lot of value, also think about the complexity behind the use case that you want to implement. This is just an example, what we did with an e-commerce startup or small company in southern Germany. And here we sat together with the team there and asked, okay, what are use cases that are generally possible to solve with AI and machine learning? So this is everything you see here on the right-hand side, but also what impact does it have on your business and how complex will they be to implement? And of course, you don't want to focus on the use cases which are very complex and have a low business value. You really want to start with use cases that are quite easy to handle, to implement, to test, and also have high value for your business. And of course, it looks very different for you. So it can be that, customer lifetime value for this e-commerce retailer has a very high value and is very low complexity because they have all the data, they have all the return data from the customers, how much they normally spend, what the basket size is. So for them to bring this all together and use machine learning in order to predict better customer lifetime value was quite easy. But for your use case, it can be quite different. So customer lifetime value is maybe if your customer just buys once your product, maybe this might be a little bit less valuable, but at the same time more complex. So our recommendation here is really to sit together, maybe with a team of experts who can help you with this metrics, but think about use cases where you can create a lot of value in a short time with less complexity. And with that, I now want to kind of paint a picture around what DataRobot does and how this all fits together. So DataRobot is a company which was founded 2012 in the USA, so in California. The first 3 years, quite differently to other startups nowadays, were really focused on building the product before launching something. And then from the day one, it was always the focus to really hire the best and the brightest data scientists in order to really have a product that is 10x, 100x better than what is out in the market. And that really comes back to what I explained earlier with the software as a service solution, that you want to really leverage those investments of companies like DataRobot for your benefit. On top of that, DataRobot is platform agnostic, which is also important for a lot of companies nowadays. You don't want to put all your eggs in one basket, so to say. And very important, I think, for everybody listening, and what we want to show now in the use cases, but also in the demo, is that we have a wide variety of customers. Of course, we have very large customers, you know, the top 10 banks, or many of the top 10 banks and insurance companies. But also we focus on a lot of smaller, medium enterprises and startups, because everybody, as we said in the beginning, wants to work, needs to work with AI, and really wants to leverage and should leverage this first mover advantage and the massive opportunity in front. And with that, I now want to hand over to Lucas to go through a couple of real-life examples, what we did actually with customers with our platform, to really kind of put it all together before we jump into the demo, so you can have a better understanding how AI can work for you and what we from DataRobot can help you to achieve that.
Perfect. Thank you, Niklas. Exactly. So these are just a few examples to also talk a little bit about the breadth of where machine learning can really be applied. It's typically not one single use case, right? And then you're done. It's really, a range of things in various industries. So there's use cases in almost every single industry. So to give you a few examples, this here is an e-commerce customer of ours in Germany. They're doing fashion retail, and we actually did quite a few things with them already, even though they're only customers since less than a year. Mainly around demand forecasting. That is typically the main problem that retailers have. It's a tricky problem because you need to think about time series, finding those patterns, potentially new trends coming up, and what about the new autumn collection that comes in where you don't actually have any history to learn from, right? So all of these things we can actually solve using ML. So you can see this sales forecasting, and then customer lifetime value, as we already touched on the question about how valuable is each customer. And when I then try to, for example, prevent a customer from churning, right? Typically, I would give them some vouchers. Basically it costs me money to keep the customer. The question is it even worth doing it, right? So they typically go hand in hand together. You can see the results down here, what it actually meant in financial terms. It's not the largest organizations, and you can see it's quite a significant benefit that they got out of this use of machine learning. Maybe we can go to the next one. So yeah, a fintech. These guys are all about kind of small credits, loans that they do. And in this industry, the important thing is, of course, to know if a loan is going to default or not, right? If they're going to get the money back, basically. So it's all about the risk. And it's a very kind of classic machine learning problem that has been done for hundreds of years, right? Only now the technology obviously is more advanced. We don't use very simple linear techniques anymore, statistical techniques. We now use machine learning techniques, which are just that much more accurate. So we can better differentiate between good customers, valuable customers that we may want to give a better rate on their loan as compared to others. We can see here they had some problems, right? Some 30% of their loans were denied, but that didn't really tell the full picture, right? The credit score alone that you get from third-party providers is only one value of many that you can consider. And if you can kind of go deeper there, add additional input data, and then run machine learning, you get quite significant returns of investments, again, as we can see here. Maybe go to the next one. So yeah, this is a manufacturing problem all about kind of predictive maintenance. So this is an kind of in the aggregates industry. a customer of ours, and they basically produce very large, very expensive machines, not very many of them, right? So there's only a few of them in existence, and they are the only producer of these machines. If one of these machines fails, that costs them millions and millions per day, right? So what they really want to do is they want to prevent that from happening. Unfortunately, here, the problem is they don't actually have any good, reliable historical data, because these machines, luckily for them, right, they never really failed that much. 3 times they failed already, but this is not a lot of data to then start building predictions on top of, right? We don't have that much training data. So what we do instead is we use something called anomaly detection. So basically, they have a lot of sensor data that measures all sorts of aspects of this machinery. And what we can do is we can see, are these sensors normal, right? As in, 9 out of 10 days, they would show these values. Or are they kind of somewhere out of the normal range in some sort of combination? And because you have many, many sensors, hundreds of sensors potentially, even kind of interactions between different sensors, right? You need to take this into account as well. So what we do here is we use time series anomaly detection to track those sensor readings, not only one sensor, but many over time, and try to find any abnormal patterns there, and deploy that in real time at each location where these machines sit, to then give a kind of risk score out. And when this risk score is high enough, they will send a person there to have a deeper look, right? In the end, there's a human in the loop, but now they have a kind of early warning system in place to, prevent, hopefully, the next failure, which would cost them millions. It hasn't happened yet, so no numbers here yet, but there's a potential, right? If you go to the next one, quality assurance, again, in the manufacturing industry. Here we are talking about a kind of steel manufacturer in Germany. They asked the question of some of their products were of lower quality and therefore not as competitive on the open market. And basically they wanted to know what actually leads to the quality degradation in these end products. Now, each product actually undergoes a manufacturing process, which is they actually measure a lot of things in the manufacturing process. And in the end, they had like 2,000 different parameters, right? Measurements of each product. And they wanted to know, well, which of these 2,000 are actually then influencing our end product. So what we did is with machine learning, and I'm also going to show that, of course, later, trying to break that down, reduce this huge amount of parameters that you could potentially look at to only a list of 20. And then with that, they went to the experts, right, in this industry, and they had a closer look at this. We also looked at some patterns that these machine learning models found, and they didn't identify some indicators that were actually unknown to them because it was just so much data to look at, which they can now use in order to adjust their manufacturing processes in order to get a better end product, which hopefully gets better prices on the open market. So this is a kind of a broad example of only 4 use cases. I'm very happy to go a little bit deeper in the end of the session, in the Q&A part, and in the further discussions to talk a bit more about that. I really wanted to show you the breadth, right? The very different applications of machine learning. And the next part will be me showing you, well, how do you actually get there? So just a very quick overview, right? What I want to do is I want to show you the DataRobot platform, which is what has been used in order to fulfill or to actually bring all of these use cases into production, into life. And we use the DataRobot platform, which is an end-to-end platform for anything machine learning, and then, of course, deployment of these models, right? Very important to note, the users of the platform can be experienced data scientists with a PhD and all of the maths and kind of programming background, but they can also be people from the different business units who are very close to the problems typically, but may not actually have a very deep understanding of the maths and stats behind the machine learning models that are typically required. So we want to enable these personas as well to make use of predictive analytics and to gain the insights. The platform itself consists of various tools like data preparation, the automated machine learning part, of course. You can also see something we call Auto TS. That's our time series product to do the demand forecasting, to then develop those models. But then this is actually the main reason why a lot of these problems fail. We need to get those models into production and we need to keep them there. That's actually the main point. Right? Getting them somewhere deployed, getting the first prediction out is actually quite easy, but having this model still deployed in a year from now and not having to spend all of your time, all of your cycles on maintaining these models, if you then have 10 or 20 or 100, right, in some instances in deployment right now, that's the tricky part. So this is where we have our kind of MLOps framework, which takes care of a lot of these things you need to do, right? Like monitoring the models, making sure the accuracy is still up to speed, automatically retrain models, and ensuring that you can actually get the predictions out in an automated way via all sorts of integrations to databases, APIs, etc. And yeah, the last part I want to mention here is the types of data that you can actually use is quite diverse. So if you have textual data, categorical data, numerical data, images, maybe even geodata, right? Like locations on a map. All of this information can be of use. And then some of the use cases I talked about have actually been used to get more accurate predictions out. And I want to show you in the demonstration now how this all fits together. Everything else on this kind of slide really shows more about like where things can be deployed, etc.
Exactly. Yeah, definitely. And this is what we're gonna also share in the last slide. You can test DataRobot. You can do a free trial with our data, and then if you want to go a bit deeper, and this is really something which can or will impact your business, which it certainly will, then we can also discuss, of course, a specific price that hopefully works for you, but also, testing it out with a pilot or what we call a proof of value in the meantime. But yeah, really important to understand, we're not just going to throw a platform at you and then leave you alone. It's a very versatile platform. You can do a lot of things with it. And that's also where we have a DataRobot University. We have tons of documentation. We have a very active community. And it's always, a platform is one thing, but you always have to put a little bit of effort in and learn it, and have, of course, the documentation and the learning path ready in order to make most of it. So that's extremely important for us to support along the way.